And not every site will be responsive, which is actually can be a good thing. Because you need to know where that top end is. Everybody wants to know the bottom. When do I need to apply some? But we also need a top end so we know when not to apply, so that we can be, more efficient and good stewards of our fertilizer.
Welcome to the Crop Science Podcast Show by Wise Genetics. I'm your host, Leo Bastos, Assistant Professor in Integrative Precision Agriculture at the University of Georgia. Today, we welcome our guest, Dr. Corey Bryant. He's an Assistant Professor in Soil Fertility and Agronomic Research and Extension at the Delta Research and Extension Center of Mississippi State University. Corey, welcome to the Crop Science Podcast Show. It's great to have you here with us today. And to get things started, I want to ask you to share with us a little bit about your background and what was your path to where you are today?
Thank you. Yes, definitely. Thank you for having me. Excited to be here and be a part of your podcast. Just a little bit of my background. I grew up in southeast Arkansas in a small town, Monticello. Has a small university there. My dad was an extension ag economist, worked up into administration from there. While, my parents did not farm, grandparents on both sides did a little bit in farming. My maternal grandfather ran cows, had chicken houses, northwest Arkansas. Paternal grandfather was a chemical rep and had about 40 acres of cotton in Plainview, Texas, that he kind of played around with. And so grew up around it. Enjoyed ag, went to the University of Arkansas-Monticello for my bachelor's, with a major in plant and soil sciences, agronomy, and had a little bit of a non-traditional route through school. So I started my bachelor's degree, and then I joined the National Guard, where I'm still in, working on 16 years as a helicopter mechanic doing sheet metal work, repairing any airframe the Army flies. So that's been nice. I tell people that's my hobby. It's my side job. But then went on to decide I wanted to go to grad school, and went to Texas Tech University in Lubbock. Got a master's in soil science. While I was in West Texas, and having spent time out there with grandparents living there when I was younger, I saw and experienced where they were running out of water, and so I was like, if it can happen here, it can happen even back in the Mid-South where I'm from, in the Southeast, where people generally consider those areas to be wet. So I ended up at the Delta Research and Extension Center with Mississippi State University for my Ph.D. I worked under the irrigation specialist, who's my major professor, but I was trained, I like to say trained as a systems agronomist. There is no degree in irrigation, but so I took a wide breadth of classes, a lot of fertility, a lot of soils, that I hadn't already taken in my master's, weed science, pathology. I like to say jack of all trades, master of none. And I think that served me well as, opening up to be able to do a lot of different things. So I guess a little bit of a timeline, I should go back to that. Started my bachelor's in the fall of 2005. Actually started as animal science. Got to stay in the ICU because of a run-in with a cow. I was working on a beef cattle farm and decided animals were not for me. I enjoyed the plant and soil science courses better, and they didn't kick back. Changed majors, finished up plant and soil science. Did have a year off in there to go through basic and AIT for the National Guard, that initial training. Graduated there May of 2011, started at Texas Tech in August of 2011, graduated with my master's in December of 14. For those listeners doing the math, that's a lot longer than it normally takes to do a master's. Also did my first deployment in my master's, went to Kuwait for 9 months, as I like to say, a government-funded vacation. And then, like I said, ended up in Mississippi at the Delta Research and Extension Center for a Ph.D. in January of 15. Was a full-time research associate, so it took longer, to finish that degree. Also had a deployment in there. But, as a full-time RA, you're limited to 6 hours a semester, so it just generally takes longer. I traded time for money. And so, but also had a big project that needed 4 or 5 years. Project there, we were looking at tillage and cover crops and a soybean production system and effects on agronomics, growth, development, yield specifically, economics. Like I said, my dad was an economist, so I was always, growing up told if it can be the best practice in the world, but if it doesn't make money, it'll never get adopted. And so I definitely, looked at the economics, but then we also looked into, irrigation application efficiency, runoff volume, infiltration, those factors, and nutrient transport and water quality. So like I said, it's a very large project, and it needed 4 or 5 years of data, to really, to fine tune everything and get some good answers, and document those changes. So that's kind of up through grad school. In high school, I worked for the extension entomologist, basically as a cotton scout, scouting research trials. You think going back looking at that, I would have ran away from academic research, because as a student worker, you get all the worst jobs. But, that just kind of instilled, a love of research and having a question and finding an answer, and trying to become better. And then going to that for a little bit. Also in my undergrad, worked for a production farmer in the region as a rice and soybean producer. Main thing I learned from that was if I so much as look at a rice field, I get muddy. I cannot be near a rice field and stay clean. And so, and from that also I learned, that I really enjoyed from the questions and the answers being able to help those producers. Because let's be honest, if our producers go under, even you and I working for a university, we don't have a job anymore either.
That's right. Yeah.
So ultimately, that kind of, in working in that production environment, instilled the wanting to help the producer and make them better, make them more efficient, and use their inputs and resources more wisely. So after I finished my PhD, graduated in December of 19, I accepted a assistant professor position with the University of Georgia at the Tifton campus. I was the extension overall grains agronomist. Most everyone there called me the corn specialist. That was the number one crop I covered, but I also covered soybeans and any small grain. So wheat, rye, triticale. As I was mentioning to you, but before we started recording, my very first extension call was to look at canola, and an agent called me and said, "What do you know about canola?" And I was like, "I'm too poor to afford olive oil, so I cook with canola oil. That's all I know." And he's like, "Well, I need you to come look in a field." So the only thing I ask is, can you send me a few pictures before I get there so I can do a little research and try to learn something? So I like to tell people, if it wasn't cotton, peanuts, or hemp, I learned very quickly I had to include hemp in that. They were probably going to call me, or a vegetable, but the agents and the growers knew who the vegetable specialists were. But row crop wise, pretty much if it wasn't cotton, peanuts, or hemp, I probably covered it 12 months out of the year, always had a crop in the ground. Really enjoyed it in Tifton. Still stay in touch with several of the faculty there. Made really good friends, but in uh, late 2020, Mississippi State had several people retire or leave for other positions from the Delta Research and Extension Center, and they called and asked if I'd be interested in coming back. And while we enjoyed Tifton and the people we worked with, my wife and I, and um, 2 hours from the beach and a lot more to do than Greenville or Leland, Mississippi. The opportunity to be closer to family um, was a bigger draw. I had our daughter, our first child, while we were in Tifton, and so with that, we're like, if we could be 2 hours or 4.5 hours from family instead of 10 hours or 14 hours from family, it was just a bigger draw. And so it ended up coming back to Stoneville and the Delta Research and Extension Center. And we've been really happy since we've been back with, happy in my role and in what I'm doing and being closer to family. So that's kind of how I've ended up where I am, what led me into agricultural research and going to grad school and, um, just kind of quick life story.
Yeah, no, this is really fantastic because you come from this, like your grandparents having this farming background. You come from that. You work with cotton and being a student worker with scouting fields, and you go through this process. You have this amazing opportunity to work with the National Guard and having that experience, which I would imagine is very different from the crop experience you had. So, and then coming back to crops and grad school. So it's a fantastic story. Thanks for sharing that. It's really, really, really nice to hear, this beautiful path.
Did you know that on average you lose approximately 1 bushel an acre during harvest? Header loss and threshing loss due to wear and tear on your equipment can lessen your yield and profits. CNH Reman Wear Parts is a drop-in ready solution made from high-quality steel that lasts longer than the competition and is covered by an industry-leading 24-month warranty. CNH Reman is helping farmers have on-time delivery of their harvest. Visit your local Case IH or New Holland dealership for details.
Could you share with us a little bit of the projects that you are conducting in Mississippi now? So you mentioned that you work a lot with soil fertility. You work with different crops in Mississippi. Can you just give us a little bit of more context of both the crops you're working with, the important crops for Mississippi agriculture, and also some of the projects you have related to them?
So I do it's to say I work with all crops, all row crops in Mississippi, predominantly, or that's going to be cotton, corn, and soybean. Those are the predominant crops. And then this year is my first year getting into rice research. And so in corn, we're doing some work right now to update our phosphorus and potassium fertilizer recommendations. Again, came back to Mississippi, start talking to growers and consultants and getting a lot of questions about our fertilizer recommendations in corn. So went back and did research into those on when they were last updated. And it had been a while, based on the data I could find. And so last year we started a concentrated effort to update those recommendations. We're in year 2 right now, and with plans to do that at least one more year. Have done a little bit of work with biologicals in corn, specifically some nitrogen fixing biologicals, and trying to determine if there was any benefit to that. With cotton, we're doing a little bit of some potassium work, trying trying to figure some things out there. Of course, a lot of questions. I believe these are nationwide questions, potassium and cotton. I know a lot of my colleagues in other states are doing a lot of work with potassium and cotton. And a lot of them are leaps and bounds ahead of me. And so I'm just trying to learn from them. Um, and but soybeans is probably my biggest uh, crop I work in. That is our largest commodity crop in Mississippi. Our soybean specialist says, in any year we're going to be around 2.2 million acres of soybeans, plus or minus 1 to 200,000 acres, which is with a lot of people just kind of blows their mind that it can be, oh yeah, plus or minus 200,000 acres. But that is our largest commodity crop, row crop in Mississippi. Doing a little bit of potassium work there as well. Have a project looking at, some delayed in-season timings and, what does that do with recovery and then, leaching and movement of potassium in the soil. Have, several, other, some soil sampling type trials. I also, one of those in corn. Doing some, again, evaluating biological products in soybeans. That's a lot of questions on that right now from our growers. And, do they work? Do they not work? Do I need to spend the money on them? So we're doing a lot of evaluating of those. And that trial is 4 locations spread around the state from, here in Stoneville, which is kind of a top end environment, consistently making 80, 85 bushel soybeans, down to dry land, flat planted location that last year the drought got so bad they didn't even make a crop. So we're just trying to, get a lot of different environments and really test these. And because you look into them and a lot of people will tell you it's site specific. And so we're just trying to identify as many variables as we can without overloading ourselves and, trying to help our growers out. And in rice, we're doing a little bit of some row rice work, some nitrogen work in row rice, because that's a practice that's gaining popularity in Mississippi. The traditional flat planted continuous flood with levees. Once you made that decision, you were kind of locked in because we do most of our tillage and seed bed formation in the fall because of heavy rains in the late winter, early spring. So we want seed beds in place in the fall. That way, as soon as it gets dry, we can plant on time. And so with row rice, depending on what markets do, input cost, all of that, if they're going to grow rice, but then they decide to go to beans, that they have a seed bed there they can plant into and furrow irrigate. Or if they were looking at soybeans and rice looks good, they can grow row rice, and it's very minimal changes to their tillage and field prep. So I say I have a little bit of nitrogen work in there where there's some questions. So yeah, that's just kind of what we have going now. Looking to in the next couple of years getting into some more agronomic work, potentially some rotation type work and rotational effects on fertility, projects of that nature.
Awesome. And I do want to follow up. So I mean you're doing amazing work in different directions. And I want to bring 2 of those back to follow up on. So the first one that you mentioned about updating the phosphorus and potassium recommendations. I guess if anyone here either has taken the soil fertility class or if you work with crops and you do fertilizer recommendations, we always have these formulas of, normally is either related to your goal or perhaps your soil test levels, depending on the nutrient. But there are these formulas, right, that we follow, that we get to a decision of, given your conditions, this is how much you should apply. But I don't think a lot of people actually fully understand how those formulas even are created, right? Like what types of trials and what type of data is actually backing up those formulas so we get a good, accurate recommendation out of them. Can you explain a little bit more about that? Since you are updating the recommendations in Mississippi, like how many trials do you have? What types of treatment you're looking into? You know, what's the complexity of that type of study that is needed for you to come up with an updated recommendation formula?
Right, yeah. So definitely, I can go a little more into that. So yes, like you said, there's always the formula. So here in Mississippi, our phosphorus and potassium recommendations are based on soil test levels. I know when I was in Georgia, and in cotton especially, they had some yield goal based potassium recommendations, but even those always started with a soil test. Um, and so to set these recommendations, we do nutrient rate trials. Um, so for mine, there's 6 treatment studies. Treatment 1 is always a no fertilizer control, and then have 5 different rates of whichever nutrient. In this case, either P2O5, the phosphorus, or K2O in the potassium. And so we just identify multiple sites. But because the larger this data set is, the more data we have, the more accurate these recommendations can be. I've heard different fertility scientists, say one of them said they wanted 60 site years before they were ready to update a recommendation. Another fertility scientist I've heard has mentioned they want 2,000 data points before they're ready to update a recommendation. Now that doesn't mean you need 60 years if you're going on site years. That is, each location within 1 year counts as a site year. So we have these rate trials, and we go out, identify areas, we soil sample them to determine our initial starting nutrient levels for the test area, and then we lay out our plots and spread the desired fertilizer, and we balance other nutrients, make sure, if it's a phosphorus, we make sure nitrogen, potassium, sulfur, all of that, none of that is limiting. And then we put out our rates for desired nutrient. And then it's pretty much, we just, watch it, monitor it, and then harvest and see if it was responsive. So in a responsive site, that is, we applied more fertilizer, we got more yield. And not every site will be responsive, which is actually can be a good thing, because you need to know where that top end is. Everybody wants to know the bottom. When do I need to apply some? But we also need a top end so we know when not to apply, so that we can be, more efficient and good stewards of our fertilizer. So we do that. Year 1, believe we started with 8 locations around the state, some of them on university research farms, some of them on grower farms. We just find growers around the state that are willing to let us put the trial in and work with us and, increase our amount of variability. And then this year, I believe we have 12 locations. Hopefully they all make it this year. I said last year, I think started with 8, we finished with 6. One location got 3 different hailstorms in one night, and there basically wasn't a crop left in the field, so we had to scratch it. And then another location was the university research farm that had such a bad drought that they didn't even make a crop. So we had to drop that location as well. So it is kind of hit or miss.
Yeah.
You do a lot of work, and at the end of the year, you cross your fingers and hope some of them were responsive. So that's kind of, we do those, and then we'll bring the yield data in at the end of the year. We determine was it responsive or not, and and then we look into at what rate was it responsive, and and compare that back to the initial soil test level, and do some regression analysis and statistics, and make these response curves that, okay, if we started here, we were up to this level, we were responsive. And then we'll also, we try to always bring in an economist, because the law of diminishing returns, just because I can apply more fertilizer and make more yield doesn't necessarily mean I've paid for that fertilizer. So again, that's how we just look at those response curves and identify, the optimum rate based on starting soil test level, and then put it in where we get percent, chance response, and that's how we set those recommendations.
Nice. Thanks for that explanation. It's really interesting to hear that. As far as whenever we say updating a recommendation that's related to soil fertility, there's a lot of really hard work that goes behind it. It's not just a simple one study you do a couple of years and that's it, right? There's all that, as you were saying, there's variability you want to explore as far as different environments, different soil types, different conditions that you find in the state to really make sure that algorithm represents those conditions. It's a lot of hard work. Yeah.
Right, yeah, and that variability, like you say, one thing we do here in Mississippi with our potassium, especially recommendations, that will vary based on our cation exchange capacity, our CEC, which generally the higher that number is, the more clay you have. So, a low CEC of sand like y'all will have there around Tifton in South Georgia, we may not need as much potassium on that soil texture to reach a desired yield, because it doesn't get bound in the soil as readily. Whereas on a heavy clay, our rice ground, if we're trying to grow soybeans on that, we're going to need more potassium because it'll get tied up more. So just trying to identify and comb through and mine through all of those little details, and to be as most accurate as we can.
Absolutely. So I have another question I wanted to follow up with you is the use of biologicals, especially in corn. So I know there's a lot of universities working on this topic, and there has been different types of results that have been reported. So what are you seeing as the results in Mississippi when it comes to the use of biologicals in corn?
So the trial we ran in corn was specifically looking at nitrogen fixing biologicals, and could we reduce our nitrogen rate, fertilizer rate, with incorporation of a biological product. In general, the results from that trial, now we only had 2 locations in that trial. It was kind of a very constrained trial. Results were basically non-conclusive for that one. We are going back and looking into that trial, into the data a little deeper, and what did we do the first time, and if we want to revisit, what do we need to change? Because I won't write them all off. I think there can be some good products out there and products to come. We just need to find where they fit, and the project we ran specifically, again, like I said, was non-conclusive. But I won't go as far as to say that absolutely means they do not work. We are revisiting, because there were a few aspects and components in some of the data collection that showed some promise. It just never translated into yield. Most of our yield just tracked our nitrogen rate. But again, like I said, as you really dove into it, there were some aspects where they seemed to provide some benefit. Where we're just kind of reevaluating. Yeah, and I know you asked specifically about corn, but in our soybean trial, there's based on location, there's definitely some differences across location. I would say with biologicals, my takeaway right now is that you need to know what you're trying to achieve with adoption and implementation of a biological in your system. They're not silver bullets. You're not, just apply biological and all of my problems are going to be fixed. I'm going to get an extra 5 bushels per acre of corn. You even talk to the companies that are developing them, and they will tell you, our product is developed to do this. And the next company, that they're developed to do X, the next company is developed to do Y. So if a grower is adamant about adopting a biological, testing a biological on their farm, know exactly what you want that biological to do, and then do your research into the different options, because there are a lot of options right now, and make sure you select one, or if you're going to do some testing, 2 or 3 that are marketed, that to do what you want to do. And so that's my key takeaway from them right now is, that they're not a silver bullet. You can't just apply one and it'll do everything for you. They are designed and developed to do specific tasks, and make sure you have a goal and that you select one to do to meet your goal.
Absolutely. Understanding that need and selecting something that's going to most likely match that.
Right.
Perfect. All right. Well, if you're listening to this episode, make sure that you drop us a like, that you follow and subscribe to our podcast, and also share this episode and other episodes with someone you think that may be interested and enjoy this conversation as well. Well, Corey, thank you so much for sharing your thoughts. I really appreciate having you here today. I learned a lot from you. I'm sure our audience will also appreciate our conversation. So thanks for taking the time and being here today. Appreciate it.
All right. Thank you for having me. I really enjoyed it.